So it looks like there's a little bit of confusion going on as far as like how to plug it in. So I'm going to start from the very beginning. When you use the quadratic formula, so first of all, we're not factoring right now. We spent the last 5 days factoring, so I'm switching it to quadratic formula. When it comes to the quadratic formula, it's a big, long, fancy formula, but I asked you guys to do it a certain way. But before we even get to that, there's a couple things we have to make sure we understand. It only works if the problem is equal to 0. So this one's it's ready. The quadratic formula uses a bunch of A's, B's, and C's. So we have to make sure we understand where to find that information. So these quadratics are usually set up in A, B, C order. So like the A is the number in front of the x squared, so that would be 1. The B is the number in front of the x, that would be -1, and then the C is -6. So then when we plug it in, I asked you guys to plug it in a certain way. So I'm going to use some colors to illustrate that. So the formula says -b, so I'm going to put b inside of here, which is -1, plus or minus the square root, and then this is the part that we were actually doing. The square root of b squared, so it's -1 squared, minus 4 times a, which is 1, and then times c, which is -6. The reason why that's in red is because when we first did this, that's what I told you to do first, because it makes it a lot easier. So then the bottom is just 2 times 1. So all the stuff in black, we can just like kind of simplify. So I have -1, that's 1. And I have plus or minus. I'm going to have this square root. And then I'm going to have it all over 2. So the stuff that's in red, we type it in the calculator. -1, what is that? I think that ends up saying 25. Well, this is 24, but I still have to add the 1 to it. So I think overall it's going to be 25. So the issue here is the square root of 25, it has an answer. So that square root is actually going to go away. So I'm going to bring the work back up here. So I have 1 plus or minus regular 5 all over 2. So when the radical goes away, we can actually combine the like terms on the top now. This problem is actually 2 different problems. It's 1 plus 5 divided by 2, and then it's 1 minus 5 divided by 2. So on the top, this is 6 over 2, so that's 3. And then on the bottom, that's -4 over 2, so that's -2. So our answers for this, because that's what this formula is figuring out. It's figuring out the answers for x. The answers are x equals 3, let's see, and x equals -2. And you might recognize that problem because we've already done it before. It was in the 5.1 notes. Same exact problem. And when we did it by factoring, we still got 3 and -2. So what I'm going to be doing for kind of like the rest of the semester is I'm going to be revisiting the different methods of solving. The first one we did was factoring. We spent 5 days on it. I showed you 1 of each type. And then now we're going to go back and redo all of them using the quadratic formula. Okay, so we're going to start to sort of put some big ideas together. So this chapter, well, the last couple of chapters actually had to do with like quadratics and their graphs and all kinds of stuff, zeros. There was a lot of key features that we've been sort of talking about since day 1. The other thing that I want you guys to know, there's a paragraph here on the side. I'm going to highlight some stuff that I think is important for you to know. So when you guys have polynomial functions, that just means that it's got all kinds of x's with all kinds of different exponents. That's what a polynomial is. When we graph them, they're kind of wavy. They're smooth. They're not like, they don't have any sharp edges at all. Usually because they're curvy, they give us minimums and maximums, which you guys should already know the definitions of, or how to find them. Well, the thing about this is you can tell a lot by the polynomial just by looking at its picture. There is a spot, usually at a maximum and a minimum, that we call a turning point. And so if we count all of the turning points, so let's look at this. So we got right here. That's a turning point. This one right here, it's also another turning point. And then this one right here, it's a turning point. So we call that a turning point because the graph is changing directions. This graph has 3 turning points. So the way that these polynomials work is if we were to look at the actual equation for it, the exponent is going to be 1 more than the turning points. So since this has 3 turning points, and it's right here, look at it. The exponent, the highest exponent of this polynomial is going to be 4. The exponent, well, let me rephrase this. The connection between the highest exponent, which we call the degree, and the picture and its turning points, if you look at the degree of the equation, it's going to have 1 less turning point. So the degree right here is 4, but the turning points is 3. So if I gave you a problem that said x to the 7th, it's probably going to have 6 turning points. Because if the highest degree is 7, turning points is always 1 less. Now some other things that kind of interesting is, and we've already talked about this, we've talked about zeros before. This graph, it looks like it has 1, 2, 3 zeros. Now take a look at the exponents though. We've been talking about this all semester. How many zeros is this supposed to have? Well, it's all based on the highest exponent, right? It's supposed to have 4. So here's the issue. It's supposed to have 4, but we only see 3. So I'm going to show you some stuff that's kind of interesting. So if this 0 right here, this 0 says that it's at -4, that actually means that the polynomial that gave us that is x plus 4. Right? That's, you know how like we always do the opposite because it has to set equal to 0 and you solve it. So that means this one right here is going to say what? If it's at 3, what's this going to say? Yeah, it's just going to say x minus 3. Now, let's look at this last one. This last one right here, it's going to say what? X plus 1. So when I look at it like this, there's still 3. But I hope you notice that, you see how the x plus 4, it passes through it? And then the x minus 3 over here, it passes through it? If you guys look at this x plus 1, do you guys see how it hits it and bounces back off of it? The reason why that happens is because there's actually 2 of these. That's what happens when you have 2 answers that are the same. When you look at the graph, it actually doesn't cross the x-axis. It hits it and then comes back. So in a way, if I had this graph, I could actually come up with this entire problem just by finding all these parentheses and then multiplying it all out. So you can do that for any problem. So again, let me just make sure you guys understand what I'm saying. If I gave you a graph and I drew it, let's see, if I drew it like this, how many turning points does this have? So if it has 2 turning points, that means that the degree is what? It would be 3, yeah. The degree is always 1 higher than the number of turning points. So we know that the problem for this is supposed to say x to the 3rd. Just by having this graph, if we knew what these numbers were right here, we could actually come up with the actual entire equation of this graph. So let me just make up some numbers. I'm going to say this one is -3, and I'm going to say this one right here is 5. So if I was going to come up with the equation for this graph, I need to come up with each set of parentheses that gives us those as zeros. So this one on the left, if it's at -3, what would this one say? It would say x plus 3. The one on the right, it would say x minus 5. Are there any that are double? Do you understand what I'm asking when I say that? I'm asking you, is there anyone in this picture that's supposed to have a second copy of the same parentheses? Like the exponent of 2 on the last one. Which one is it? Yeah, so you can tell because it hits it and it comes back. This one is not, the 5 is not the one because it passes through it. If it passes through it, usually that means there's 1. If it hits it and bounces back, that means there's 2. So if we wanted to come up with the actual equation for this, we could take x plus 3, and then x minus 5, and we could multiply it all out and get the actual equation. So that's the thing that's interesting about this stuff is you can come up with a lot of stuff just by knowing this from just the picture. I gave you two numbers, and then you can come up with the entire equation. Okay, so here's what we're going to do now. Today's stuff is just it's calculator work. That's all you have to do today. I'm going to give you like, I don't know, I think the assignment's like 10 questions. So today's thing is going to ask you, just by looking at the equation, not the actual graph, just the equation, to find all of the numbers that could possibly be the zeros for that equation. So it's actually, it's not that bad. I mean, it's a little boring, but it's doable. So here's what you do. These graphs, no matter how they're set up, they always have a constant term. The constant term is the number at the end that doesn't have a letter. So this, we call this the P. We need to look at two numbers in this entire equation, and that's how we can come up with all of our possible zeros. So we look at the constant term, and we look at the leading coefficient. The leading coefficient is the number at the very front of the problem. So this one right here, this would be our Q. So what we would do is we would make a list of all of the factors of those two numbers. So think of the, you know how like we make the list and we try to circle the pair that we need? What would the list for 9 say? It'd be 1 and 9. So I'm going to do it like this. 1 and 9. And what else? 3 and 3. Okay. Now I'm not going to write 3 and 3 twice. I'm just going to put it once. So these are the factors of 9. And then the factors of 2, that's a pretty easy list, right? It's just 1 and 2. So here's what we do with that. In order to figure out what numbers could possibly be zeros, we would create a fraction, every possible fraction that you can make using those numbers right there. The only catch is the P's always have to go on top. So these numbers, they have to go on top all the time. These numbers have to go on the bottom. So here's how we're going to attack this. You guys, the way I think about this, I think of like the distributive property. When I set up my fraction, I'm going to start with this one right here, and I'm going to put it over the one that's down here. It's supposed to be P on top of Q. So what's 1 over 1? So that's just 1. And then we got 1 over 2, so that's just 1/2. And so since that one paired up with those two already, now I move on to the next one. So 3 over 1. What is 3 over 1 simplified to? Just regular 3, right? And then I go 3 over 2. So 3 over 2 is another one. Once I pair up the 3 with the 2 down here, now I move on to the 9. 9 over 1. And then 9 over 2. Now the other thing about this is we don't actually know if they're positive or negative. We just know that it has to work like that. So what we do is we go back and we just put plus or minus on every single one of these. Now this problem is supposed to have 4 zeros exactly. Bless you. If you could just stop doing that because I'm recording my video for YouTube right now, that'd be great. I'm serious. Yeah, I always record first hour for YouTube. Okay, so here's what you guys need to know. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 possible answers, but there's only actually 4 that are going to work. So what we do is we go into the calculator, we type this in, 2 to the 4 plus something to the 3rd minus 19 something squared minus 9 plus 9. And we go in and test every single one until we find all 4. Now that sounds like a scary task, but you don't have to retype this every time. You just go back up in your calculator and then change the numbers. So when it asks you to find all the zeros, the exact zeros, it's just a calculator test. Test them by plugging them in and finding the ones that actually give you 0. And then that's how you find all your zeros. Was there another page of this? I don't remember. Is there a second page? What does it say? Find all the rational zeros? Yep. Let's do it again. So I'm not concerned with this part. You guys can figure that out on your own because you just do it in the calculator. The parts that I want to make sure that you get is this part right here. This is the most important part because that's the stuff you have to put into your calculator. And if you set that up wrong, well then you're going to get the bottom part wrong. So let's go over one more time how to get those numbers. So out of this entire polynomial, the only two numbers that matter are this one and this one. Which one's the p? Yeah, it's always the one at the end. So this is the p. That means this one is the q. The reason why that's important is because we're going to try to set up all the possible fractions using the p factors on top and the q factors on the bottom. So let me first list all of the factors for p. So if the factor for that is 4, I'm going to put 1 and 4. And then we got, 2 and 2, but we don't have to write it twice. Okay, so those are all the factors for p. And then I take the q. Q is another easy one. It's just 1 and 2. So this question is saying find all the rational zeros. So in order to do that, we need to see what all the different possibilities are. So what we do with those factors is we set them up in a fraction using p on top and q on the bottom. So let me try to illustrate this one more time, what I was trying to say. I want to start with just the 1. So what I'm going to do is I'm going to put the 1 on top of this one, and I'm going to put the 1 on top of this 2. Those are my first two fractions. So I got 1 over 1, that's just 1. I'm going to simplify that. And then 1 over 2. So once I've paired that 1 up with the two numbers under it, I move over and I do the next one. So now I go to this one. I put that on top of this, and I put this on top of this. So 2 over 1, that's just 2. How about 2 over 2? Yeah, so I'm not going to write that again, because then I'm going to end up checking the same number twice. So it simplifies to 1, so I already got that. Then I move on to the next one. So I go to the 4. I put the 4 on top of this one. I put the 4 on top of this one. So 4 over 1, that's 4. And then 4 over 2, that's 2, and we already have it. So then the last part to this is to put the plus and minus on all of these, because we don't know what sign combination this needs to be for our polynomial. Now, these are, let me tell you what these are. These are all possible zeros. Is that how you spell zeros? Oh. I've seen it with an E before, and it messed me up, so now I can't tell anymore. Now, Z-E-R-O-E-S, like toes, kind of. But I've seen, so these are not the answers yet. These are just the possible zeros. In order to find the actual answer, we would go into this problem, plug them all in, and make sure that we just find all 3 that makes 0. And then those are the ones that we would list. So you see, it's not saying find all possible zeros. It's saying find all of the zeros, all rational zeros. So we would have to take this one more step and go into our calculator and actually plug it in. So for your assignment today, that's all you're doing. You make these lists, you type them in the calculator to check, and then tell me which ones make the zeros. Yeah, that's all it is. When we set this up right here, this is telling us, it's narrowing it down because really there's an infinite list, right? But there's a pattern that happens between the first number and the last number when we factor, and those are all the possible combinations that it would create using those two numbers. So instead of having this infinite list where we randomly just try it and see if it works, we narrow it down to 2, 4, 6, 8. There's 8 numbers in the list now instead of having an infinite list. Because you know how hard that would be? You're like, let me try 7. No. Let me try 13. No. So it actually just narrows it down. It narrows the list down to a smaller list. And I know it seems like it's a lot, And it kind of is, but again, it's all just done in the calculator. And that's it. So the rest of the time is yours. You got 30 minutes, so you can rock out on these calculators. So your assignment is going to be all, I think it was 10 questions. All 10 questions.